Okay, let's go over the free response portion of Chapter 8 test. Write a balanced chemical equation for the following reaction. Iron plus copper 1 nitrate yields iron 2 nitrate plus copper. So that's going to be iron, that's Fe, plus copper 1 nitrate. Remember, copper 1 is Cu plus, nitrate is NO3 minus, so copper 1 nitrate is going to be CuNO3, yields iron 2 nitrate plus copper. Don't just look at the left side or the reactant side when you're writing the right side. You're going to run into trouble. You got to write the correct formula of iron 2 nitrate. Iron 2 is Fe2 plus. Nitrate is NO3 minus. So the correct formula for iron 2 nitrate is FeNO3 2. And then the correct formula for copper is Cu. Now we need to balance. We have one iron on each side and one copper on each side, but we have two nitrate ions on the product side and only one on the reactant side. We need a coefficient of 2 here, and we need a coefficient of 2 in front of the copper now, and everything's good. All right. Tell what type of chemical reaction is represented by the following formula equation, then balance the equation. C3H8, that's propane, plus oxygen forms carbon dioxide and water. Remember, when you have a compound of carbon and hydrogen only, that's a hydrocarbon. And when it reacts in oxygen, that's a combustion reaction. It's a burning process, and the products are carbon dioxide and water. So the reaction type is combustion. Okay, and then now let's balance. When we balance combustion reactions, typically you want to balance the carbons first, then the hydrogens, and the oxygens last. You'll always get the correct answer if you follow that method. So there's 3 carbons in propane, so I need 3 carbon dioxide molecules to get 3 carbon atoms on the product side. There are 8 hydrogens in propane, so I'm going to need 4 times 2 is 8 hydrogens on the product side. And now I have a total of 6 oxygens there and 4 oxygens here. That's 10. So I need 5 oxygens. 5 times 2 is 10. And now it's balanced. Tell what type of chemical reaction is represented by the following formula equation. Then balance the equation. I can see that there is a typo. This should be an S. Okay, so I fixed that. Let's carry on. All right. So FeBr3 aqueous plus FeOH3, or sorry, plus MgOH2 aqueous forms FeOH3 aqueous and MgBr2 aqueous. Okay, when you have 2 aqueous solutions and then you end up forming a solid, this is a double displacement and it's a precipitation reaction. So we're going to write double. The ions swap partners, so it's a double displacement. Okay. So now let's balance. We have, again, 3 bromine atoms here, 2 here. We're going to need at least common multiple of 2 and 3 to balance those out, which is 6. So I'm going to put a 2 here to get 6 bromines there, and I'm going to get a 3 here, and that'll give me 6 bromines. So in order to balance magnesium hydroxides, I'm going to need 3 of them, and I'm going to need 2 iron 3 hydroxides to balance the irons out now. So let's do a check on ourselves to make sure that we balance this correctly. On the reactant side, we have 2 irons, we have 6 bromines, we have 3 magnesiums, and we have 6 hydroxide ions, 6 O's and 6 H's. Since the hydroxide ion didn't change, we just balance the hydroxides and makes it easier. And on this side we have 2 irons, we have 6 hydroxides, we have 3 magnesiums, and we have 6 BRs, and it's balanced. Great. Okay. Remember, you can balance polyatomics if they don't change. If this was a neutralization reaction, you have to remember that the OH is going to change into water. So that's not going to work as well for you. Okay. Use the activity series to determine if the following reaction is possible. If it is possible, then write the products and balance equation. If not, explain. Not the best example in the world, but because potassium will react with the water in the aqueous solution much faster than it will the zinc chloride. But let's just pretend that this was molten zinc chloride and it's a single replacement. So potassium is higher on the activity series than zinc, which means it can displace zinc from the compound, right? It's an element in a compound. It's set up for a single replacement style reaction, and so we get, it is going to occur, and we're going to get potassium chloride. I'm going to write this up here so I don't fall into the mistake of trying to write the formula for potassium chloride while balancing, and we're going to get zinc metal. Now, the potassium, what's the formula for potassium chloride? K is +1, it's an alkali metal, and Cl is -1, so the chloride ion is -1, it's a halide ion. So that's just KCl. Again, don't make the mistake of writing KCl2. It's not. Zinc's a +2 ion, that's why there's 2 chlorides for every zinc. Potassium's a +1 ion, that's why there's 1 chloride for every potassium. And then we get zinc. Zn. Okay, now balance it. There's 2 chlorides. I need 2 chlorides on this side, and it's good. All right. Predict the products and write balanced symbol equations for the following reactions. Barium nitrate solution. Barium is a 2+ ion. Nitrate is NO3-. So the formula is BaNO3 2. And its solution, so I'm going to write aqueous, plus sodium sulfate solution. Sodium's +1. Sulfate is SO4 2-. So that means it's Na2SO4. And that's also aqueous. And we're going to write, now this is a double replacement reaction. I need to go to the solubility rules, and I need to check the following combinations on solubility. I need to know if sodium nitrate is soluble, and I need to know if barium sulfate is soluble. All nitrates are soluble, and all alkali metal salts are soluble, so sodium nitrate is definitely soluble. Barium sulfate, however, many sulfates are soluble, but silver, lead, and barium are not. That means barium sulfate is a precipitate, and this reaction does occur. So now I need to write the correct formula for barium sulfate. Barium is 2+, sulfate is 2-, so that's going to be BaSO4, and that's a precipitate, so I write an S. And then the other product is sodium nitrate. Na is +1, nitrate is -1, so that's just NaNO3, and that's aqueous. So now I can balance. I have 2 sodiums on the left. I'm going to put a 2 here, and it looks good now. Okay? Great. Copper 2 carbonate. This looks like a decomposition reaction, so I'm going to write Cu, CO3, and I'm heating it up, or I'm decomposing it. Now, carbonates, when decompose into an oxide plus carbon dioxide. So I'm going to get copper oxide. Again, copper's plus 2 there, so it's going to be CuO. This copper is plus 2 and oxide is minus 2. And carbon dioxide. Carbonates decompose into oxide plus carbon dioxide. It's balanced already. Okay, aluminum plus hydrochloric acid. The formula for aluminum is Al. The formula for hydrochloric acid is HCl. Right? Hydroic acid is a binary acid, and that means it's the chloride ion with quote-unquote H+. It's not ionic, but it acts like it is. Or, you know, from writing a formula, you can write it that way. Now, to decide whether or not this reaction occurs, you have to look at the activity series because you have an element and an acid, and you need to look and see, is Al higher than H on the activity series? Will it displace H plus from a compound? And indeed it is, and it does. So when you have an acid and a metal, you displace hydrogen from the compound, so you're going to get hydrogen gas. Hydrogen gas is H2. It is not H. Hydrogen is a diatomic element, so it's H2, and you're going to get aluminum chloride. Well, aluminum is a plus 3 cation because it's in group 13, and chloride is a minus 1 anion, so that formula is AlCl3. Okay, so an acid plus a metal will form a hydrogen and a salt if the metal's high enough on the activity series. Now we can balance. Balance aluminum last. You have complete control over that on the reactant side. So balance the chlorides first. We have 3 chlorides on the product side, so we need a 3 here. And then we see that we can only have an even number of hydrogens on the product side, see, because there's 2 here, so that 3 is not going to work out for us. What we need to do is, instead of having a 3 HCl, we're going to need to have 6. And then we'll have an even number of H's and 2 aluminum chloride. So now we have 6 HCl. We can go for a 3 H2 and 2 Al, and it's balanced. Okay, so 2 Al plus 6 HCl forms 3 hydrogens and 2 aluminum chlorides. Okay, the last one, and that's single replacement. This one is decomp. Okay, nitric acid, ic, that's from the nitrate ion, 8 ite us. Okay, so that's H plus with the nitrate ion. Nitrate is minus 1, so it's HNO3, aqueous, plus barium, barium's Ba2 plus, hydroxide OH minus. You need parentheses here. BaOH2. Okay, and now you have an acid plus a metal hydroxide. That's an acid plus base. It's going to form a salt plus a water. So the salt is going to be barium nitrate. And H and OH are going to make water. So don't try to balance it just yet. Just write the correct formula for barium nitrate. Ba is 2 plus, nitrate's NO3 minus. So the correct formula for barium nitrate is BaNO3 2. All nitrates are soluble. And H and OH make water. And that's a liquid. And now I can balance it. Okay, I have 2 OHs on the left side, and they're going to make 2 waters. So I need 2 H pluses with each OH minus to make 2 waters. And now the nitrates, NO3, there's 2 on the left side, there's 2 on the right. Barium, 1 on each side. This looks pretty good now. So hopefully seeing those examples worked out will help you have a better preparation for the test, and a better feeling about how to write predict products of chemical equations and how to balance them.